Hey guys, this is lesson 5.3, solving rate problems. You've already learned what a ratio is, you've learned what a rate is. Now we're going to use rates to solve some problems. So the most common rates that you need to know is talking about distance, speed, and time. So this is a very common formula in math that we use all the time. My algebra students right now are having to memorize this. So if you can remember this now, it'll help you in the future. So in words, we say to find the distance traveled, D stands for distance, so D stands for distance, multiply the speed, R. So R is the speed because a speed, like miles per hour, we learned in the last lesson, is just a rate. So R stands for rate by the time T. So this is time T. So then, really fast in algebra, we tend to say rate times time equals distance because it has a very nice flow. It flows right off the tongue, and it's easier to remember. So rate times time equals distance, and that's something we're going to use all the time. Also, you can mix it up a little bit, and you can do rate equals distance divided by time. This is the same thing as miles per hour. So usually when we write it as a fraction, we write miles on the top and hour on the bottom. Keep in mind, miles is just your distance and hours is just your time. So you're already familiar with miles over hour equaling your rate, miles per hour. But now we're putting it into a formula where rate equals distance over time. And when you get into algebra, I'll explain these formulas a little bit more. But right now, just know we're going to be using them a lot. Okay, so let's go to the first problem. A peregrine falcon can dive at a speed of 80 meters per second. How far can it dive in 4 seconds? So it's saying how far. So we're looking for distance. So we're going to have to do rate times time equals distance. So our rate is 80 meters per second. So this gets a little tricky because what you do is you put 80 meters per second. Keep in mind the per means it's going to be a fraction. Okay? So 80 meters over 1 second, and then we're going to times it by 4 seconds. Okay, a little side note. I hope you remember that if you have, let's see, we've talked about this briefly, but let's see, what can I say to help you understand this? What if I said 2 over 2? You should know now that you can cancel those 2's out and put a 1 and 1. Or what we've done in the past is 1 over 2 times 2 over 3. Because the 2's are on the top, we can cancel both of those out and make them 1's. That's the same thing here. 80 meters over 1 second times 4 seconds is the same thing as times 1. Or 40 seconds over 1, because you're making 4 seconds into a fraction. Now you can see seconds is on the top and the bottom. If the word seconds is on the top and the bottom, we can actually cancel it out because we want to end up with just distance, and distance will just be in 1 unit. Okay, if you have any questions about this, please come and see me, because this can be quite tricky, and I'll be happy to explain it to you. So 80 meters over 1 second times 4 seconds over 1, we cancel out the seconds, and then we just multiply. You end up getting 320 meters all over 1 if you truly multiplied the numerators, the denominators, which is 1 and 1. But anything over 1 is just itself. So the 1 on the bottom isn't really necessary, and we can just leave it 320 meters. Okay? So 320 meters is our distance because we multiplied our rate times our time. So the peregrine falcon can dive 320 meters in 4 seconds. Okay? Before we said per second for 1 second. Now we wanted to know in 4 seconds. Okay? Next example. A great white shark dives 90 feet in 2.5 seconds. What is its speed? Keep in mind, speed is a rate, so we're really looking for our R. So this time we're using the formula rate equals distance over time. So now we just have to take our 90 feet in 2.5 seconds. And whenever we do this, you want to simplify it to a unit rate so that we can then give it a really nice statement like 4 feet per second. But once you do 90 divided by 2.5, you'll see that it's just 36. But it's still 36 feet in or per 1 second. So its speed is 36 feet per second. All right, because we really want to include both of the units, feet per second. And whenever anything's in a unit rate, we tend to use the word per because it's more mathematically used. All right, next example. How high does the hot air balloon rise in 15 seconds? So how high? That's a distance question. So we're going to be using the formula distance equals rate times time. Keep in mind there's two methods for this problem. So first off, we're going to just stick with the distance equals rate times time. And you want to get your rate, and your rate over here says 9 meters in 3 seconds. So that's 9 meters in 3 seconds. So that's going to be our rate. And again, we're going to cancel out the seconds. But just like when we could cancel out diagonally when we're multiplying fractions, you can do the same thing here. We can cancel out the 3 and the 15. Since 3 goes into both of those, we can simplify the 3 into a 1 and the 15 into a 5. So now we can just go ahead and multiply and we get 45 meters. So the balloon rises 45 meters in 15 seconds. All right, what's the second method? The second method is to use our unit rate. So we can take our rate and make it into a unit rate. So the same rate that we have over here, if you look at it, it's very easy to turn into a unit rate of 3 meters in 1 second. And then you can use that to multiply, and you can still get 45 meters. The only difference here is you're simplifying your rate before you start your equation, rather than up here in method 1, when we simplified it during our equation. Okay, but you pick whichever method you want to do. Simplify at the beginning, simplify in the middle. You're still going to get the same answer. And you can also simplify at the end. So really there's 3 methods. But still the balloon rises 45 meters in 15 seconds. We're not going to simplify that because it specifically asked how high does the balloon rise in 15 seconds. All right. I believe this is the last example. 4 bottles of fruit juice cost $7. How much do 9 bottles cost? So the best rate is to first find the unit rate. Or maybe I should say the best method is to first find the unit rate. If we can figure out how much is 1 bottle, then it's not going to be hard to figure out how much 9 bottles is. So if we know that 7 bottles cost $7 is for 4 bottles, you can divide the top and the bottom by 4 to make it a unit rate. Once we make it a unit rate, all we have to do is multiply that unit rate times 9, because we're not buying 1 bottle, we're buying 9 bottles, and we can get 9 times $1.75 is $15.75. So 9 bottles cost $15.75. All right, that's the end of the lesson. Go ahead and work on your classwork and let me know if you have any questions.